Hey guys, welcome back from spring break. I hope you had a good one. Yeah, right. All of you know we're going to be doing this for a little bit longer. So we're just going to continue on. Again, I'm going to try and chunk this out for you the best I can. We have a little ways to go yet, and we will have a test on ladders. I'm going to address what tests will look like for us. I mean, for you guys, I think most of my tests are already loaded up, so we can probably just do normal testing. But I think I'm going to change it up a little bit because this is different. So um, we'll figure that out along the way. Okay. For now, let's just go ahead and get into this. We're learning objective number 6, describing the proper process for placing ground ladders. So basically, here's what we're looking at. You kind of already had some of this opportunity to look at this. I've been putting the ladders up outside, and you kind of starting to see a climbing angle and how that ladder should be placed, 4 points of contact kind of thing. And we'll discuss that right now. So observe and communicate. When we're talking about ladder assignments, we're talking about situational awareness. Communication is key. We need to be able to talk about what we're actually doing. I don't mean, having a conversation beforehand. We need to bark out orders. We need to know what each other are doing and what the commands are as far as what we need to do next. Some of these ladders require 2, 3, sometimes 4 people to actually put it up. So we need to be good at communication. Presence of overhead electrical wires and obstructions. Overhead clear. Okay, if I'm at the butt section getting ready to lift this ladder, I'm going to be yelling out overhead clear. If it's clear, okay. If it's not clear, then I'm going to make sure people know this is not the spot. Overhead obstructions are present, not clear. Ground condition, ground's good. I'm going to go ahead and make sure that we've got a level spot to place the butt section of our ladder, the butt spurs, the pawls, whatever we have going down. Make sure that they're seated correctly and have good ground. We're not on the side of a slope. We're not in a muddy section of the ground. We're not in a path of egress, a place where somebody might be coming through. So we have a good place to put that ladder. Building structural integrity. There's certain things we're looking at. We've got some pretty heavy smoke coming out of a brick facade building. That may not be a good spot to place a ladder because that may be some idea that section's starting to weaken. So let's take some building construction and understand what you're looking at. But if the building doesn't seem to have some integrity on it, then that's not a spot we want to put it. Wind direction and speed have a lot to do with this, and that's going to come into ventilation. We'll talk a little bit more about that here in just a bit. Appropriateness of the chosen ladder. Again, we're talking about the length of the ladder, knowing that a 24-foot ladder is basically going to make it to the second story roof. Window is probably the best spot for it. For rescue, we're going to go a little bit more than that for the second story roof, but this will reach the second floor window. A roof ladder is not used for us to climb. It's used for stability on the roof, so that's another reason that ladder is going to be used to be on the roof. Structural features of the building. The understanding what we're putting our ladder up against. Again, if we're putting it up against concrete, masonry work, is it stable, strong? Is it a place we want to be? If we're putting it up against a parapet, I know that I need to identify how deep that parapet is so that I can expect to bring another ladder to actually get off the ladder and down to the roof. Those types of things. We're looking at that kind of stuff. Ladder placement objective, position ladder properly for its intended use. So this will be our fly section ladders. The fly section is in or out. The wooden ladder, I believe, fly sections are meant to be out, and the aluminum ladders, fly sections are meant to be in, if I can remember correctly. And I'll make sure I get that information for you. And this is just proper placement of those ladders, making sure we're using them correctly. Again, the roof ladder is not meant to climb to the roof. It's meant for stability on the roof. There would be no reason for me to bring a 45-foot banger ladder with stay poles to a single-story house. That's pointless, so why would I be even thinking about doing that? Place the butt section proper distance from the building for easy, safe climbing. So this is a climbing angle. We're going to have an idea of how far out we should actually begin our ladder raise. And I'm sorry we didn't get a chance to actually do this at school. If we have time when we get back, we'll talk about doing this. But we're going to have a place where we set the ladder to begin our climb. It is not always the perfect climbing angle when we start the raise of the ladder. We will have to adjust it. And you're going to see here in just a little bit how we actually adjust that. So difference of placement between ventilation and rescue. Ventilation is where we're actually trying to remove the smoke, superheated gases out of a building, maybe using the windows. And then rescue is specific to itself. I mean, that's where we're actually going to save someone, and we have a purpose or a reason to actually save someone. So, upwind side of the window for ventilation. So, in other words, if the wind is blowing this direction, I want to have my ladder up here, the window's on this side, right? Because the wind's blowing across and it's pushing the smoke. If I actually open that window up, it's going to push the smoke away from me, not into me. I'm going to get smoke when I'm up there regardless. But if I've got wind pushing from me toward the smoke, then I'm clearing that smoke out. Visibility is okay, and heat is not going to increase too much on me. Tips, even with the top of the window, we want to make sure this ladder reaches the top of that window, because we're going to come up and we're going to have to break some glass. I don't want to be sitting under the window when I break that glass, because it's going to rain down on top of me. So off to the side, above the window, break the glass. It all falls to the ground, making sure nobody's underneath, or whoever's underneath knows, hey, here it comes. Use when firefighters need to climb in or out of narrow windows or direct hose streams into them. So in this respect, after we've opened that window up, we can use this to enter into a structure at that point. Or if we need to direct fire streams directly into it, we can use that as well. Just happen to see something. Let's see if I can fix this for a second. Okay. So the rescue tips slightly below window seal. The wedge tip under seal for stability. So if there's a window seal, we're going to wedge it up underneath, and it's going to kind of give it some more stability as far as not slipping, technically not slipping underneath us. Extend ladder 2 or 3 rungs above the seal if there is room to permit the tips to project into the window and allow room to enter the rescue beside it. So what it's explaining here is, sorry, open that back up. What's explaining here is, if the ladder is up against the window, but the window's wide enough that we can set it on the right or left windward side, we can actually enter the building. So we can come 2 or 3 rungs into that window to help us get out into the building to pull the person out and slide down the ladder. If the window's small enough or narrow, then it needs to cut underneath. Okay, it can't actually go in because we've broken or stopped our egress from that respect. And I got a little picture here I want to show you guys. Kind of just explain this. Now you're looking at some placements for rescue. Here's a roof ladder. No reason to be there. It's just for demonstration purposes. It's right below the window. This window can open. We can go in, come out. Same thing up here. We can go in, we can come out. These windows are kind of wide enough that we could actually come to the right or left, and we could have that sticking up. It looks like they're just a little on the narrow side. So if there's just a little more space, then we could put those tips 2 to 3 rungs in to allow us to actually pull someone out. Okay. All right. Sorry, guys. Loading. All right. So ladder placement. Place ladder near at least 2 points or different sides of the building. So we want to have, an extra exit is the whole point there. Avoid placing ladders over openings where they might be exposed to heat or direct flame. I can't even fix that. It's just kind of stuck there. Take advantage of strong points in building construction. Raise ladders directly in front of the window when it is used as support for a smoke ejector. We'll talk about that when we talk more ventilation. What a smoke ejector is, it's a big fan, and so we can use that ladder to actually hang those fans in some cases to help pull smoke out or inject air in and push out another window. Avoid placing ladders where they may contact overhead obstructions. And so in this respect, again, we're looking at wires as our big thing, or something that's overhead that's going to impede us from actually putting that ladder up. Avoid placing uneven terrain or soft spots. A muddy, grassy area is not going to be a good spot. If we got a bunch of mud there, it's going to become soft and start to slack on one side or the other. We're going to be falling off the ladder, or it might slip out from underneath. So avoid placing in front of paths of travel. So we got people going in and out of the front door doing rescue and interior work. We can't put it in front of the door. It makes no sense. So we're going to have to come to one of the sides of the doors. Avoid placing on top of sidewalks, elevator, trap doors, or deadlights. Does anybody know what deadlights are? I don't know either. Okay, we'll talk about that later. Avoid placing on top of sidewalks, elevators, and trap doors. Kind of a no-brainer. Put on top of a trap door would be a stupid thing. An elevator in New York, they still have ground elevators that come up from the sewers, basically, spaces down below up to the sidewalks. So be careful of that. We don't have that kind of stuff here. But the sidewalks, again, we saw that one video in the snow, the fire, they had it on the concrete, and it was not a good spot to be. So we do want to have some sort of foothold. The ground is better, not concrete, if we can avoid it. Do not place against unstable surfaces. Never. Climbing angle, distance of the ladder. So this is important. I want you to hear this because you're going to do a little assignment later on based off of this. Distance of ladder, butt from the building, establishing angle between ladder and ground. So we're talking about the distance away from the building to create the proper climbing angle. If the ladder is too close, its stability is reduced. So if we come too close to the building, the ability for it to keep its position on the ground, keep itself stable, is reduced. It's not going to work well. It's going to start to rock on us and move around a bit. If the ladder is too far away, as we load it up, it's going to be too much to handle. It can actually bow and bend that ladder. And if you've ever been on a ladder before, no matter what, they always start to bounce and bow. The longer they are, the farther you climb. But we want to minimize this by having the proper climbing angle. Optimum angle with certain expectations. Now, sometimes it's just not going to work out right. And if we have to kind of have it at a more than a 75-degree angle because of obstructions around us, we still need to get there. We have to make sure it's secure, not just somebody holding it, really. We have to have it secured, roped off, tied off, so that it does not move. And there's some really unique ideas for this. And I'll see if I can find the video I saw recently to kind of show you how to use some of your tools to make your ladders more stable. So that climbing angle, again, is 75-degree angle. And this will be a simple assignment you guys will have with Google Draw. You'll explain basically how ladders should be placed using Google Draw. We'll talk about that later as well. That won't come today, just so you know. To determine proper distance, sorry, one more time. Proper distance, determine proper distance of the butt from the building. Divide the working length of the ladder by 4. Okay, so this gives us the idea. We can take a ladder basically and say that it's a 24-foot ladder divided by 4. We come up with our distance away from the butt section away from the wall. And so that's part of what your assignment will be later this week as far as Google Draw is concerned. Oh, sorry. I'm getting confused now. Too many buttons to push. So load that back up, last one, and here you go. Another way to look at climbing angle, okay, is to actually place your feet at the butt section below, arms straight out. You should be at a perfect angle right here, 90-degree angle, perfectly. Your ladders will show a sticker on the side, looks just like this. Shows you if this was upside down, this guy would be upside down. So it's pointing to the out, and the fly section is pointing out. And then we set that climbing angle properly. Now, if you're not good at math, this makes it simple, right? Once you get the ladder placed, you put your toes up against it, grab the first rung in front of you, perfect 90-degree angle, you're right where you're supposed to be. But if you have the ability to do your math real quick, you can take the angle, and it's quick measurements. You're not taking a tape measure, measuring perfect distance. You're saying this looks like 3 feet, 4 feet, 5 feet. We're right where we need to be. So it's figuring out your proper climbing angle, making sure the ladder is going to be stable, secure as you climb it. Okay. So that's it for basically placing ground ladders for use. I'm going to go ahead and post up a couple of questions related to this lecture, as well as post up just the lecture itself, the PowerPoint, so that you have an idea of what to actually. My family's giving me a hard time right now. Going to go ahead and answer those questions, please, and make sure those get turned in, okay? Other than that, that's all I have to say right now, and we'll talk again soon, okay? Thanks.